Hi, my name is Dave Whiteley. I'm Technical Director of Envisage UK Limited, and I'd like to take this opportunity to run through with you some exciting additions to the Autodesk Product Design and Manufacturing collections for this year. So, since Autodesk have moved from product design suites to the product design collections, you are receiving the following products in your product design and manufacturing collections, but the two new additions to this are Autodesk Nastran In-CAD and HSM for CNC machining. So first I'd like to go through the integrated HSM CAM with you. We believe at Envisage that design and manufacturing should be part of one seamless workflow. You take time to learn an interface. You've taken a long time to learn Inventor over the years. So really you want to keep using this interface for additional products to the collection. And this is what they're doing with HSM. So HSM, we've had two levels. We've had three levels in the past, but we've now got two levels of HSM available to us. We have HMS Express, which has always been free with Inventor, and that gives us 2.5 axis milling. But with the addition of HSM Ultimate to the Product Design and Manufacturing collection, we've now got the ability to program machine tools from turning all the way up to 5 axis milling, along with probing as well. So the integrated CAM gives us a streamlined workflow. It gives us a simplified data structure. It also gives us the full CAD functions prior to milling, and also enables us to import any third-party CAD file into Inventor as well, using any CAD. The benefits of using the CAD prior to milling in the same interface is that we can fill holes, we can model extra solids for work holding and fixtures and so on. We can import our popular CAD formats, so STEP, ASYS, and then third-party CAD files. We can also maintain associativity to our CAD files as well, whilst we produced our CNC machining code. The features that we have with the 2.5D or 2.5 axis milling, we have 2D adaptive clearing, we'll talk about that later, facing, pocketing, slotting, engraving, drilling, core, and circular and thread milling as well. So these are typical CNC coding where we're moving into an 2.5 axis, so simultaneous at X and Y and then separate in the Z axis. Then we have full 3-axis functions, so from adaptive roughing all the way to 3+2 machining, which is 3-axis simultaneous with 2-axis positional. And then 5-axis functions where we've got 5-axis simultaneous. We also produce 4-axis wrapped toolpath for 4-axis simultaneous machining as well. And then turning, the typical turning, so grooving, threading, roughing cycles, finishing and so on for turning, but also we provide coding for mill turn machines with live tooling. And then additional functions, so we've got stock model and rest machining options. This is where you would go in with a smaller cutter afterwards, and that would tickle out the material that's left after a larger cutter has been in there. We've also got slope-based machining where it will change the offset of the machine in path based on the slope of the component. We have a CNC editor incorporated. It also allows us to produce probing, automatic setup sheets, and verification of the toolpath. One exciting addition to HSM is the fact that we've got adaptive clearing. So the roughing cycles will adapt the toolpath so that we've got a constant chip load. The load on the tool is constant. So you can actually run at maximum feed throughout the cut. This is really, really important, and it also will extend the tool life and give you a shorter mill time. The most important thing, no matter how good your toolpath is, you need to post-process the code out to the G code or whatever code your machine tool uses. HSM includes a library of post-processors. These are all user configurable. They are available at that website on the page now. And here at Envisage, we've got decades of CNC experience from the team here, from 5-axis CNC machining for the aircraft industry, for instance, and we can edit the post processors for you, the customer, as well. Here's a quick email that we've had from a customer about our work with them on the HSM machining, which we're very pleased with, obviously. And let's just go through a short video on the CAM, the HSM CAM within Inventor.
Autodesk HSM CAM software helps you to manufacture quality parts and significantly reduce CNC programming time, boosting your revenues, enabling you to compete and win more business. Our fully integrated CAM solutions run inside Autodesk Inventor, SolidWorks, and Fusion 360, allowing you to design in whatever system you are comfortable with. Whether you're machining simple parts or using 5-axis milling, mill turn, or turning, we have a powerful integrated CAM solution that perfectly fits your needs. Autodesk HSM offers 2.5-axis CAM software for free, allowing you to machine accurate and high-quality prismatic parts. Our 3- and 5-axis solutions inside Inventor, SolidWorks, and Fusion 360 Ultimate allow streamlined and intelligent workflows that dramatically reduce programming time for complex parts. All Autodesk HSM solutions include adaptive clearing, the industry-leading high-speed roughing strategy that reduces mill time and extends tool life. Our high-speed finishing strategies produce high-quality surface finishes, allowing you to ship parts right from the shop floor. With complete post-processors already available for many machines and new ones always being created, you're able to machine parts right out of the box. Also, leverage our built-in collision detection and simulation tools to give you the confidence to run unattended. With seamless CAD integration, best-in-class performance, and high-quality results, Autodesk HSM CAM solutions offer the most effective tools to grow your business. Discover the best integrated CAM software for you and get started on manufacturing your parts today.
So that was an overview of the Autodesk HSM integrated CAM within Inventor as part of your product design collection. Now let's have a look at the Nastran In-CAD that comes with the software now. Nastran In-CAD was developed by NASA more than 40 years ago, and it's incorporated inside of the collection as Nastran In-CAD. This enables you to reduce physical prototypes, improve time to market, increase product functionality, and predict product performance. The main questions that we ask ourselves when we're designing is, will my design fail? Can my design be optimized? Can we reduce the weight, for instance? Can I get to market sooner? With the question, will my design fail? One of the most important things with a product is fatigue. We can analyze a product with linear and nonlinear analysis, but what about fatigue over many, many cycles of a load? What about vibration from motion, nonlinear deformation and failure? We might be working with plastics or rubber where we have nonlinear materials, or we might want to analyze over time. We might also want to analyze the thermal loading. Can my design be optimized? Can we reduce the number of components? Can we change the material? Can we reduce the weight or the part thickness? Can we improve component quality? All these questions can be are answered really by using Nastran In-CAD. Can I get to the market sooner? Reduce physical prototyping, the number of physical prototypes that I have to create. Can I use simulation to reduce those numbers? Increase virtual design iterations, understand how to simplify design safely. The advantages of Nastran In-CAD over Inventor's FEA that we've had in the past is the fact that we've got extensive clamping possibilities. We have bolted connections now. We have many types of contacts. We have nonlinear analysis. We have frequency response. And most importantly, we have the ability to analyze fatigue and many more capabilities as well. If you look at this simple analysis where we run a linear static analysis of a load on plastic, you can see the deformation is 7.6 inches, which is incorrect because we're going beyond yield. So we have a non-linear stress strain curve for the plastic material. And if we run a non-linear static analysis, we actually get the correct displacement of 0.9 inches in this case. What applications are possible with Nastran In-CAD? Well, we have the basic analysis capabilities. So we have linear static analysis, we have buckling analysis, we have modal analysis, i.e. calculate the natural frequencies or resonant frequencies of the design. We have that available with pre-stress as well. We have linear steady state heat transfer analysis. We have composite analysis, assembly modeling with contact analysis, and thermal stress. With the advanced capabilities, we have nonlinear static analysis with nonlinear materials. We have nonlinear transient heat transfer, steady state heat transfer. We have random frequency response. We have linear and nonlinear transient response, so different frequency analyses. We have advanced nonlinear with hyperelastic materials. And we have impact analysis as well, such as drop testing, all inside Nastran In-CAD. So let's watch a quick video on this. I would urge you to watch this video because it actually goes through the shape generator as well. So this is worth watching.
Welcome to this technology demonstration featuring Autodesk Manufacturing Technology at work. In this example, the design team has been challenged to increase throughput of this robotic welding station. Not only will their customer benefit from being able to produce more, the manufacturer could increase market share by offering better performing products and lower overall material and production costs through reduction of material used in the design. One significant difference you will see during this demonstration is the idea of predictive versus iterative design. Autodesk's shape generator technology enables engineers to define form based on the function that a component will perform. Let's have a look. One of the new Inventor Professional tools available is something truly revolutionary. It's called Shape Generator. This approach to design moves powerful analytic tools to the front of the design process, as opposed to traditional methods after the initial design concepts are created. This workflow enables users to drive initial design intelligently as a function of the physical constraints and loads the design is exposed to, as well as density, elastic modulus, and other properties of the material being used. Once the initial shape is defined, environment variables such as fixed, grounded, pin joints, or frictionless sliding constraints are added. Subsequently, loads such as forces, pressures, moments, or bearing loads can be applied. Preserved regions may exclude zones where material will not be removed. In this example, these are areas where the pivot joint, hydraulic cylinder, and clamp are mounted. Finally, a mass removal target is defined and the shape generator solver begins. This new technique promises to transform design productivity in ways not previously possible, as the initial model shape is defined primarily by the demands of the physical environment the part will operate in. This generative shape is then merged with the initial model volume, and then any one of a number of modeling techniques can be used to remove material from the volume, leaving the minimum amount of material required to match the results defined by Shape Generator. In this case, traditional sketch volumes are created and used to remove a bulk of the material that is not needed. Direct modeling and freeform tools may also be used, depending on the complexity of the part, and the shape of the areas that need to be removed. Fillets are added for blending purposes, and finally the part is saved, and checked into the vault with the rest of the new clamp assembly. The shape generator process was also used on the main clamp backplate, and here we used Inventor's replace component functionality to swap the new for the old. Finally, these changes are driven down to the assembly, and all existing instances are updated with the new configuration. With the new clamp design, it's time to make sure that it will last for the life of the ASCO welding fixture. We can do this right in the CAD design environment. We can even use boundary conditions from the shape generator study to save time and ensure consistency. In the browser, there is the bearing load from the actuator, as well as the two constraints simulating the pin and contact with the automotive component. The material also comes over automatically and can be used for the virtual test. We could run a linear static study and simply test for stress and displacement, but that's not going to be enough. We need to know if the clamp can withstand 300,000 load cycles. This requires fatigue calculations. There are numerous ways to constrain and specify the boundary conditions. In this model, we have a hole that can only rotate along its axis. We know that there is a fastener connecting the part to the hinge plate. With the use of rigid connectors, we can then have full control over the geometry. Turn on and off the ability to move or rotate in any of the 6 degrees of freedom to simulate a pin or spherical constraint. Let's also make a change to the load. Fatigue results are based on the behavior of the actuator force on the clamp. Is it loaded and unloaded? Does the load reverse in the other direction? The actuator in this case only applies the load in one direction. These load curves are fully customizable for any load condition. Finally, let's mesh the part or break it up into smaller pieces to be analyzed, and run the study, which only takes a few seconds to calculate on this component. Taking a look at stress, we can see the value is very low. Shape Generator did a great job of finding the best possible geometry for a lightweight component. We can also see the fatigue results show there is zero damage over the life of the part. Is it possible we can make it even lighter? Why not try different material types, even plastic? Nonlinear studies are extremely powerful. They provide high-fidelity results for all material types, including plastics, rubber, foam, and more. Let's edit the material we used in the previous fatigue study and change it to UHMW. We will find out how much of the load it will handle before it yields or maybe even buckles. Nonlinear studies are highly accurate. We will spread the load out in 30 increments and observe the results as it is gradually applied. We will also increase the load to ensure our safety factor is at least 2. Unlike linear static studies, we can watch the behavior of the part as the load is applied. Watch as the stiffness of the model changes and may even cause the part to buckle. This is something you will also never find in linear static results. They will only tell you if the material is going to pass or yield. Find out more about your design with fatigue, nonlinear, vibration, and thermal heat transfer. All within the CAD design environment. Even check the displacement of the model while the analysis is running. We can see that the part does in fact buckle at 1600 newtons. This does not satisfy our requirement of 2 times the normal load condition. Animations of the results may help to understand the weak points in the design for changes that need to be made in the model. We know that the design becomes unstable at 1600 newtons. By watching the animations, we can make better informed decisions for improvements to the stiffness of the geometry. Based on these results, we can confidently move forward with the model using mild steel. Using these types of studies, we can fully understand our design and run several what-if scenarios with various materials. Now let's check the design in with a message for the rest of the engineering team. From here, the engineering change order can be approved and released to manufacturing. Autodesk provides the technology for simulation-driven modeling using Shape Generator. Also validate parts and assemblies at any point right in the context of the CAD design environment using robust solvers for various types of studies. And manage it all in a secure and collaborative environment. Autodesk is your trusted solution. It is the future of making things.
So, 2 exciting additions to the product design and manufacturing collections, as you can see. At Envisage, we offer 2-day training courses on both HSM and Nastran In-CAD. If you go to our website, envisageuk.com, you'll and the training calendar, you'll see the training days in there, or please contact us on the telephone number on the page for further information on this. So thank you very much for watching this webcast, and hope to catch up with you soon. Thank you very much.